Welcome back to physics, and today we're going to talk about ticker tape diagrams.
I've already drawn in Becca's car over there. This is her new car, by the way. She got a new one. She used to drive a Volkswagen Beetle that was all rusted out. Now she's driving a hardcore pickup truck, an F-150. Anyway, so a ticker tape diagram. What the heck is a ticker tape diagram? Basically, we're going to do this where we have this machine that produces a piece of tape. And on that tape is going to be a bunch of dots. The correlation we can give, or the analogy we can give, is Becker's jalopy. It drips oil. So when she's just sitting in one spot like this, oil starts to drip out and it leaves a puddle on the ground like this. Well, what would happen if she started to move? Well, you're going to get space between those little puddles.
So it depends on how I'm moving, how far apart those puddles will be. But those puddles are a certain distance apart, right? Just like our ticker tape diagrams, what they do is they put a little ink blot at different distances depending on how the tape is moving through it. So let's say that I'm driving along Betts Highway and all the lights are green, so I can just keep going and I'm in cruise control. So as I travel, I get some dots.
I'm just wondering, I mean, oil is usually black. That might be blood. It's Halloween.
It is Halloween, but you also have the black pen.
Yeah.
And I don't even see my controls to change my color right now.
Regardless.
Anyway.
So what's happening is, because she's moving at a constant velocity, the question is, what could we say about the distance between this dot and the distance between this dot? This dot and this dot, and then this dot and this dot. Because she's moving at a constant velocity, that means that the distance she covers every single second is exactly the same. So if we said this is 1 second between dots, well, that distance here would be the same distance here. If she's moving at 10 meters per second, and this is 1 second, well, this would be 10 meters, and this would be 10 meters.
So that's for a constant velocity. We have our dots equally spaced out.
Let's redraw that on a clean sheet. We're going to call it constant velocity.
I'll let you draw my jalopy.
Oh, I'm not going to draw the jalopy again. So constant velocity. What you would see when you get your ticker tape out of the machine, you would see a piece of paper, a long, thin piece of paper with dots on this paper. Now, some of these papers, well, some of the machines use ink, and some of them actually burn them little images. So ours, the ones that we're going to use, burns a little image, a little dot on the paper. So for constant velocity, you would get equally spaced out dots.
Now, I'm not using a ruler right now, so they're approximate, but
Let's say they're equally spaced. From this, because you don't know any information about the vehicle, but from this, you can determine how far the car went in a certain amount of time. Now, our machines have a certain amount of time that they're set to make each dot. I don't remember what that time is, but let's make up a time.
I think 6 dots is 1 second.
Let's just say our machine here does a dot every 2 seconds, right? So let's say a distance here is, I don't know, let's make up a distance, 0.3 meters between 2 dots. So 0.3 meters, and the time difference between 2 dots is 2 seconds.
So my first dot was at 0 seconds, my next dot is at 2 seconds, 4 seconds, and 6 seconds.
Now, from this information, we can calculate the velocity of the car. How would we do that? Well,
so remembering this is a constant velocity, we have a formula that we can use to figure out our constant velocity. And you should remember that that's our first formula on the back of our best friend,
second best friend.
which is that V is d over t. So we can plug some information in. What we have here is 0.3 meters in 2 seconds. And we can calculate that. Can we do math in our heads? Yay! 0.15 meters per second. That was impressive.
I know, it took a lot of brain power. All right, well, let's talk about a different situation. Let's say this car is not moving at constant velocity. Let's say Becker Stralapi started at rest. She was at a stop sign or a red light, and she starts from rest, and she accelerates forward. Well, let's first talk about what the ticker tape would look like. So you're going to name this one, draw every picture that you see us draw. Don't draw her car, just draw the ticker tape, okay? So let's call this one acceleration or accelerated motion. And let's be more specific and call this a positive acceleration. Because now she's started from rest and she's accelerating to some velocity.
So I'm going to just note that we're starting from rest, which we talked about in the last video, and we talked about in class. That tells us that we have an initial velocity of 0. So that means that I'm sitting in one place, not moving.
So let's think, before we draw anything, let's think, what would the ticker tape diagram look like? You would first have a dot where she started. And then the next dot would be very close to it because she's not going very fast. So within 2 seconds, she hasn't covered that much distance. But then all of a sudden, she starts to get faster. So what happens to the distance between dots as she continues to move? The distance between dots should increase. Why? Because she's going faster and covering more distance in the same amount of time. Remember, our time between dots is still just 2 seconds. So 2 seconds between dots.
So I'm just labeling my times where I'm at. So I started at 0 seconds at a stop, and I hit the accelerator, and in 2 seconds I got to my second dot. By 4 seconds, a little bit further, by 6 seconds I covered a lot more distance, and so on, continuing.
What we can do here is we can figure out the average velocity in between each set of dots. How will we do that? We're not going to do it for you because it's the same exact situation we just did. But we're giving you the idea of you would actually measure the distance between these two dots and divide it by the time difference of 2 seconds. Measure the distance between these two dots and divide it by the time difference of 2 seconds. With that information, you can find the average velocity here and the average velocity here. Oh, yeah, sorry, that's delta change in velocity. My bad. So it will be V bar. You can find the average velocity between these two dots and the average velocity between these two dots. Then, the next step would be to calculate your acceleration. And how would you do that?
So then we would have to go into using that other formula that we talked about, our acceleration formula, which is our change in velocity over time. And we're having one velocity here, our first snapshot of a velocity, and then our second snapshot of a velocity. So we have a sort of initial type velocity and a final type velocity. We're finding the change between them and then dividing it by how much time we're covering.
There is a slightly easier way, but you don't know it yet. So as we continue on and start talking about more formulas, we can talk about the distance that this covered and the time that it covered. And then we can use distance and time to figure out acceleration. But we're not there yet. So right now, we would use this method.
So what we're going to ask you to do is to try and describe in words and write it out on your paper, so we'll go through it when we come back in class tomorrow, what you think a ticker tape diagram would look like if we had a negative acceleration. Okay? So on your page, you should write out that we're going to have a negative acceleration.
When she says page, she's talking about in your notebook on a piece of paper.
Draw out a blank ticker tape.
Don't bother drawing the car.
And we want you to draw in what it's going to look like if I'm driving down Betts Highway and then I come to a red light, so I have to slow down and stop. That's my negative acceleration.
Let's be more specific. The car probably broke down. So, as she's driving, the car breaks down and slows to a stop.
It's just a red light. Gotta hit that brake. So we're going to ask you to input into Edpuzzle a verbal description of your dots, and then we're going to draw through it in class tomorrow.
Okay? Again, if you have any problems, show up for extra help. Have a great night.